Okay, so the topic for today is going to be continuing our journey with parallel lines, but this time we are going to start doing some proofs with them. So our essential question, the thing that we're going to try to answer by the end of this video, is how can I use a two-column proof to prove angle relationships when parallel lines are cut by a transversal? Okay, so you might remember me mentioning Euclid a while ago. Euclid is known as the father of geometry, and he wrote a book a real long time ago proving everything that we are currently learning in these videos. So this little part says, as Euclid began to prove different geometric facts, he came to the assumption that if parallel lines are cut by a transversal, then corresponding angles must be congruent. This is called the corresponding angle postulate, and we can use this to prove other angle relationships, which is exactly what we are going to do. So we got the corresponding angle postulate written out here. It says if two parallel lines are cut by a transversal, then corresponding angles are congruent. And what we're going to try to do here with our first proof here is to use that corresponding angle postulate to prove that alternate interior angles must also be congruent. So what we're really trying to do here is we're trying to prove why all those angle relationships exist, right? We've talked about alternate interior angles, alternate exterior angles, all that stuff. We're going to try to prove why they have to be congruent, starting off by using this corresponding angle postulate. So our first proof here says A and then these two lines B. And if you don't know that symbol, that is the symbol for parallel, right? So we're saying if A is parallel to B, if line A is parallel to line B, then prove that angle 1 is congruent to angle 3. Okay, so let's start this thing off here. As per usual with any proof, we're going to start with our given in the top box. And we're going to try to prove that angle 1 is congruent to angle 3. Well, first thing that I notice here is angle 1 and angle 2. Looking at my diagram, I see that angle 1 and angle 2 are, in fact, corresponding angles. And what the corresponding angle postulate says that if lines are parallel, which we know in the given, then those two angles must be congruent. So angle 1 must be congruent to angle 2 because of the corresponding angle postulate. Okay, so according to that corresponding angle postulate, since the lines are parallel, those angles are congruent. Now let's try to incorporate angle 3. Well, hopefully you guys see angle 2 and angle 3 there are in fact vertical angles. So we can use the vertical angle theorem to say that those two angles are congruent. And then what do we notice? We should notice that in our diagram, all three angles are marked as being the same. And that means that angle 1 must be congruent to angle 3 because of the transitive property. So we did it. Angle 1 must be congruent to angle 3. And that was what we were trying to prove. Okay, so one down. We've proven why alternate interior angles must be congruent. Now let's try to use that same corresponding angle postulate to prove that alternate exterior angles must be congruent. Well, let's take a look here. What do we got this time? A is parallel to B. Let's get that in our given. So line A is parallel to line B. Oh, you know what I forgot to do in the last one? Anytime the lines are parallel, we should mark them with those arrows. I forgot to do that on that one. So we know those lines are parallel. And we're trying to get 1 to 2. We can tell that 1 and 2 are alternate exterior angles. We're trying to prove that why they're congruent. Well, check this out. This time we can look at angle 1 and angle 3 because those are corresponding angles. And if those lines are parallel, then the corresponding angle postulate says that they must be congruent. So 1 is congruent to 3 because those are the corresponding angles. And then look at that. Angle 3 and angle 2, aren't those vertical? And we know that vertical angles are congruent. according to the vertical angle theorem. And then we can use transitive property. So angle 1 is congruent to angle 2 because of the transitive property. And reminder, transitive property is when you've got two things congruent to the same thing. We had 1 congruent to 3, we had 3 congruent to 2, both of them were congruent to 3, transitive property. Okay, so just like Euclid, we can use the corresponding angle postulate to prove that alternate interior angles are congruent. We can prove that alternate exterior angles are congruent. Let's go to the inside. Let's see what we got. So after Euclid's work with the corresponding angle postulate, we can now use the following theorems. So now we know why alternate interior angles are congruent, alternate exterior angles are congruent, and same side interior angles add up to be 180. Let's read those off real fast. Alternate interior angle theorem says if two parallel lines are cut by a transversal, then alternate interior angles are congruent. If two parallel lines are cut by a transversal, then alternate exterior angles are congruent. And if two parallel lines are cut by a transversal, then the measures of same side interior angles sum to 180 degrees. Very cool. So now we have access to all of those theorems. We can use any of those if we want to use any of those angle pairs. Okay, so let's try to use some of those to prove some other things. Let's look at example 3 here. So this one says A is parallel to B and B is parallel to C, and we're trying to prove that angle 1 is congruent to angle 3. So let's get those givens down. A is parallel to B, so this line's parallel to this line. Let's mark those with some arrows. And B is parallel to C. So this line is parallel to this line. Let's put 2 arrows on those so we know that those ones are parallel. And those are given. Okay, so we're trying to prove that angle 1 is congruent to angle 3. Well, let's look at, you know what? Let's look at the first given, with A being parallel to B. Now, what kind of angles do we have on A and B? We've got angle 1 and angle 2. And what kind of angles are those if we're just looking at those two lines? Well, those two angles, 1 and 2, are alternate exterior angles. And now we know, according to the alternate exterior theorem, that they're congruent. So we can use the alternate exterior theorem to say that those two angles have to be congruent. So we use the first given. Now let's look at B and C. What kind of angles do we have with B and C? What kind of angles are 2 and 3? Well, hopefully you guys recognize that 2 and 3 are alternate interior angles. So now we know that angle 2 and angle 3 are congruent by the alternate interior theorem, which we just proved why that worked on the first page. And now what do we have? Well, we have 1 congruent to 2, 2 congruent to 3. That is a perfect example of the transitive property. So angle 1 must be congruent to angle 3 by the transitive property. So life's a lot easier when we have access to all of those theorems instead of just the corresponding one, but that's how Euclid did it. That's how Euclid proved why those different angle pairs were congruent. But now we've got all the power. We can use all those theorems. All right, got a new diagram here for example 4. What's going on here? All right, so we got A parallel to B and C parallel to D. So let me jot that down, then we'll mark our diagram. Let's get those givens in there. Okay, and then we'll mark our diagram. Remember, we can use those arrows to mark parallel lines. So we know that this line's parallel to this one, A is parallel to B, and C is parallel to D, so they get 2 arrows. Okay, we're trying to get angle 2 being congruent to angle 3. Okay, so let's look at the first given. Let's look at A and B. What angles are being formed by A and B? Hopefully you guys see angle 1 and angle 2 are being formed by line A and B being crossed by line C. And what kind of angles are those? hopefully you guys saw that angle 1 and angle 2 are alternate interior angles. So we can use the alternate interior theorem to say that they're going to be congruent. And now let's look at our second given. Our second given was talking about lines C and D being parallel. Well, the angles being formed by C and D are angle 1 and angle 3. Now, what kind of angles are angle 1 and angle 3? Those are corresponding. So this is the corresponding angle postulate. So we've got angle 1 congruent to angle 2. We've got angle 1 congruent to angle 3. That's going to be enough to say that angle 2 must be congruent to 3 by the transitive property. And that's what we wanted to do. Okay, so let's get to the last ones here. Okay, so example 4. What do we have here? We got A parallel to B again. We got C parallel to D. Those are both given. And my oh my, do we have some angles flying around on this one. We got all 16 angles being listed out. Okay, our goal is to get from angle 6 to angle 16. And if I'm being honest here, we got so many options. Okay, we got so many options to do on here. There's not just one right way to do this proof. There's so many different ways. Let's go ahead and think about the lines that we know are parallel. We know that A is parallel to B. We know that C is parallel to D. Now, there's no way of jumping straight from 6 to 16. They might kind of look like they're alternate exterior angles, but the truth is that they don't share a transversal, right? Angle 6 is made by lines B and D. Angle 16 is made by A and C. They don't share a line, so there's no angle relationship directly between them two. So instead, we're going to have to build a little transitive property link here. So let's start with 6, and let's just choose to either go up or down, because angle 6 is made by these two lines. And let's travel down. We could have traveled left, but I'm traveling down. Now, traveling down line B intersects with line C. So I'm looking over here, and I'm trying to figure out which angle do I want to pair angle 6 up with. And there's some choices. We could either pick angle 10, or we could pick angle 12. Those are the two angles down below that angle 6 is going to be congruent to. I'm going to choose 10. You could have picked 12, though. So I'm going to link angle 6 with angle 10. Now, what kind of angle pair is 6 and 10? The reason that 6 and 10 are going to be congruent is because those are corresponding angles. So this would be the corresponding postulate. Okay, now we're at 6. So now let's travel, now we're at 10. So now let's travel with angle 10. Angle 10 is made by these two lines, the blue ones. And if I travel this way, I can see that now I can actually connect 10 to 16. So what kind of angles are 10 and 16? Well, those are alternate exterior. So this is going to be the alternate exterior theorem. Okay, so I went from 6 to 10, then from 10 to 16. So now I can say angle 6 is congruent to angle 16 by the transitive property. And that's how I know I'm done, because I finally accomplished what it was that I wanted to accomplish. Okay, so we're cruising right along. What's this last one got for us? We got AB parallel to CE. Oops, I don't know why I did a lowercase. Let's jot these down. AB is parallel to ray CE. And we've got ray CE bisects angle DCB. Okay. This has some interesting stuff in it here. All right, and our goal is to try to prove that angle A is congruent to angle B. Okay. So let's look at that first given. Line AB is parallel to line CE. We're trying to go from angle A to angle B. Let's start with angle A. Angle A's got to be congruent to something. And let's think about these lines that are parallel. Sometimes it's tricky to kind of imagine them because they just gave us the segment, right? They didn't give us the line. But if we imagine that these lines are extended, there's angle A, right? And if I extend it out, it intersects ray CE up here. So by highlighting it, we can kind of picture it better, like the diagrams that we've been normally looking at. And what does angle A right here match up with up there? Well, hopefully you guys see angle 1. Angle A's got to be congruent to angle 1 because those are corresponding angles. So I can use the corresponding angle postulate to say that they have to be congruent. Okay, so I went from angle A to angle 1. Now, what do I know about angle 1? Angle 1 certainly doesn't match up with angle B, but what did that second given talk about? The second given said that ray CE, this ray right here, bisects angle DCB. This big red angle that I just kind of highlighted there is getting bisected by ray CE. And what do we know about a bisector? We know that a bisector splits things in half. So doesn't angle 1 have to be congruent to angle 2 because of the definition of bisector? And guys, if I can't be more clear, if they talk about a bisector or a midpoint in the given, you better be using definition of bisector and definition of midpoint in your proof. They're not just going to mention it for fun. They're mentioning it for a reason. You got to use it. Okay, so what have we done so far? We know that angle 1 is congruent to angle A is congruent to angle 1, 1's congruent to 2. We still have to get to B. How is B involved in this thing? Well, B is made up of these lines. So this one and this one. Now, we know that segment AB down there is parallel to this line. So I know our diagram's getting kind of tricky, but look at those blue lines there. And how does angle B fit into this? Well, angle B is alternate interior angles with angle 2. So I can use the alternate interior theorem to say that those angles are congruent. And now I've built this big chain, right? A is congruent to 1, 1's congruent to 2, 2's congruent to B. So according to my diagram, at least, angle A must be congruent to angle B. And you might be tempted to use the transitive property here, but you can't because it's 4 things, right? It's A, 1, 2, and B. If it's 4 or more, this is substitution. And voila, we accomplished our goal. Okay, so now that you've got all those tools at your disposal, all those different postulates and theorems, it is now up to you to try 2 out. You got example 1 here, which is very similar to this one that we did. And then you've also got example 2, which is pretty similar to one of the other ones we did. So give those 2 a shot. Remember, start with your given, look for those angle pairs, and then come back and check to see how you did. All right, let's see how you did here. Now, on this one, honestly, you could have done it a lot of ways. Your choice here very well may not match mine, but hopefully you can still tell if you did it appropriately. So if I'm trying to get from 2 to 12, here's 2, here's 12. I'm going to start off by traveling down with angle 2 here. If I travel down, I'm going to get to 14. Let's say 2 is congruent to 14 because those are corresponding angles. So I'm going to use the corresponding postulate. And then where am I going to go from there? To go from 14 over here to 12, using my green lines there, 14 to 12 would be alternate interior. And that is the alternate interior theorem. So 2 to 14, 14 to 12, that's going to tell me that 2 is congruent to 12 by the transitive property. Since I only used 3 angles, it's the transitive property, as opposed to substitution property. Now, let me throw out some other ways you could have done that because, like I mentioned, there's a lot of ways. Maybe you went 2 to 8 alternate interior and then 8 to 12 corresponding. That would have worked. Or maybe you went 2 to 6 corresponding and then 6 to 12 alternate exterior. That would have worked. But you should have had a corresponding angles in there at some point. But yeah, a lot of different ways to do that one. Example 2 says A is parallel to B, B is parallel to C. We're trying to get from 1 to 3. Probably should have done angle 1 is congruent to angle 2 because they are alternate interior. Remember, that is a theorem since we proved that it is true. And then I can do 2 congruent to 3 because of alternate exterior. And then we've got angle 1 congruent to 3 by the transitive property. And there we go. No wiggle room on that one. That was pretty much the way you had to do it. All right. Hopefully you guys are doing good.